As you saw in the previous video, we're going to take a look at the proof of the Pythagorean theorem. First, in words. In a right-angled triangle, the square of the hypotenuse is equal to the sum of the squares of the two right-angled sides. Here we have this in symbols. So we're still working in a right-angled triangle as we did all the previous proofs. And then here is the Pythagorean theorem. So the square of the hypotenuse is equal to the sum of the squares of the two right-angled sides. Here in short or in small letters. Of course, this only applies if A is the hypotenuse and B and C are the two right-angled sides. So never start learning this by heart. Learn this because this is always true. You have to be able to apply this on any triangle. The proof. Well, the proof is very easy. We are working in triangle ABC, and we know that A is 90 degrees. To prove is the fact that the square of the hypotenuse is equal to the sum of the squares of the two right-angled sides. Well, this proof, although it is the most famous proof in math, you're going to see that it's very easy because we have our first projection theorem. And our first projection theorem was a theorem that was learning us about the right-angled side. So the right-angled side squared, AB squared, is equal to the product of the hypotenuse and its projection on the hypotenuse. So for AB, this would be BD. Same thing is true for AC. So the product of the hypotenuse and its projection on the hypotenuse, CD. If I would add both sides of these two equations, you're going to get this. On the left side, AB squared plus AC squared. And on the right side, BC times BD plus BC times CD. Now, if you take a closer look to the right side of this equation, you notice that BC is a common factor. It's a factor of this term and a factor of this term. Therefore, I can do this. I can put BC in front of my parentheses. So it is the inversion of the distributive property. Yeah? The inversion of the distributive property, because if we would do this, if we would multiply this distributively, I'm going to get this. Now, between parentheses, we notice that BD plus CD, due to the fact that D is an element of BC, and I'm going to mention that D is an element of line segment BC, therefore, we can say that BC times BC is BC squared. And this, my friend, is the proof of the Pythagorean theorem. Now, I can apply this on any right-angled triangle. In small letters, it's going to be this. Well, this indicates that in a right-angled triangle, we are able to calculate a missing side if you have either the two right-angled sides or a right-angled side and the hypotenuse. So, because of the square, we are going to say that A is square root of B squared plus C squared. You can also say that B is the square root of A squared minus C squared. Or you could say that C is a squared minus b squared. These three formulas we're going to use in the exercises. Of course, we still have the formulas that we've learned in the previous lessons, and those we're going to use combined with the Pythagorean theorem. Okay, good luck with your exercises.